morning all. Dear students, we are going to discuss today a new topic named as operations research. Operations research is a new field of science and mathematics in which a lot of problems are solved by using some of the techniques available in OR. Namely, operations research is called as OR. We can able to solve many real life problems in operations research. For example, inventory problem, queuing problem and sequencing problem, gaming problem, and many of the factory oriented, industry oriented, and there are various concepts of transportation problem and assignment problem, and all kinds of problems are able to solve by using the newly coined technology named as operations research, in which we can able to solve many problems, not only the real life problems, also in mathematical problems and scientific problems are we can solve. Particularly, this word operation is used in the military area. During the Second World War, by the peoples of America, all the peoples of America together and invent a new topic in order to get the success in the Second World War. How we can able to get success in the Second World War? By using the availability of resources, how we can able to get the maximum benefit. This is the information actually coined by the American peoples. All the American peoples are together, scientists, engineers, knowledgeable persons, politicians and other peoples are involved in this process. They have to discuss about how we can able to get benefit, get success in the Second World War using the available informations, using the available raw materials, using the available technologies. So, with the minimum available resources, how we can able to get the maximum profit is the main concept of this operations research. Okay. Now, in OR, a lot of problems are solved, particularly network problems and sequencing problem, game theory and so on. Now, we discuss in this class, we discuss the sequencing problem. What is called a sequencing problem? A number of jobs are available, 2 jobs or more than 2 jobs or n jobs are available for the processing. In order to process the jobs, we may require some machines. For example, we have to consider 2 machines. By using 2 machines, we have to process some jobs, 5 jobs or 4 jobs or 10 jobs, anything may be. All these jobs are sequentially processed through the 2 machines. That means each and every job must be processed first in the first machine and then second in the second machine. This is the sequence. Okay. There may be some times are given for solving the problem. The processing time in each and every machine and each and every job is assigned. There must be a time duration is available in the problem. Then in order to solve, that is process the entire jobs, all the jobs through these 2 machines, what is the minimum elapsed time we require to process? This is the scenario of the sequencing problems. Now, we discuss one of the problem in sequencing problem. Now, in sequencing problem, there are 2 kind of problems are available. One is n machine, 2 machine n jobs and n machine m jobs. N machine 2 jobs and n machine m jobs. These 2 are the 2 sequencing problems which are exactly available in the field. How these problems are able to solve means, there are various assumptions are available in the processing of these problems. In order to solve these problems, we have some assumptions. What are the assumptions? First, we have to assume no machine can process more than 1 job at a time. Only one machine, one job, one machine. One job, one machine at a time. Okay. The processing times are independent of processing of the jobs. This is the second property. Then third one is the time involved in moving a job from one machine to another is a very little small time. And the fourth one is each job once started on a machine is to be continued till its completion on it. The fifth one is all machines are of different types, because machine 1 and machine 2 are different kinds of machines. Okay, but all the jobs are completely known and are ready for processing before the period under consideration begins. This is the assumptions which are have in order to solve or before solving a sequencing problem. Now, already I told you there are two kind of problems are solved by using this sequencing problem technologies. Actually, this sequencing problem and other kind of OR problems are mostly solved by using computational methods nowadays, because the computational methods are very effectively utilized for solving real life problems nowadays in the world. For example, some kind of financial problem, healthcare problem, public sector problems, private sector problems, government problems, all kinds of problems are solved by using this OR techniques. Also, the OR is called as optimization techniques. What is optimization techniques? We have to get the optimized results. That means the the highest result we can able to get by using the OR techniques in order to solve a particular problem. This is the main area. This is the main area of the operations research. Now, we will discuss about a simple problems. Now, you assume there are 6 jobs are available. There are 6 jobs are available. The jobs are numbered as J1, J2, J3, J4, J5, J6. There are 6 jobs are available. Then machine A and machine B, there are 2 machines are available. There are 2 machines are available. Processing time in each and every machine for each and every job, all jobs are given as follows. That is 5 for job 1 and 6 for job 2 and 3 for job 3, 2 for job 4, 2 for job 5, 10 for job 6. Here you can know that very well. There are 6 jobs are available, 2 machines are available, in which all these 6 jobs are processed through these 2 machines. The processing time for job 1 in machine A, the job 1, that is machine A requires 1 hour processing time, machine B requires 5 hours. For job 2, machine A requires 3 hours and job 2 requires 6 hours in job machine B. Now, these are the timings. The timings may be hour or minutes or seconds, anyway else, anything else. But what is the nature of this problem? What is the nature of this problem means? We have to process all the jobs through these 2 machines in order to get the minimum elapsed time, in order to get the minimum total elapsed time. For that, which job we want to process first and which job we want to process next and go to like that. There must be a sequence we require to solve the problems. Particularly, how we can able to find out the sequence? You know that very well, there are various methods are available. How we can solve this problem? It's a sequencing problem. In order to solve the problem, in order to find out the minimum elapsed time, we have to solve this problem, in which the processing time, jobs, machines are given. For that, we first find out the sequence of jobs, which job first and which job second and which job third, and go to like that we have to find out. How we can able to find out the sequence of jobs? Here you know that very well. 6 jobs are available. 6 boxes you can put it. Now listen in the problem, in which in overall processing timings, which one is the less time, which one is the minimum time? The minimum time period is 1, 5, 3, 6. Among all these processing time, the minimum time period is 1. This is for job 1, and this minimum time period for job 1 means also you have to consider this minimum time is taken for assigned for machine A or machine B. Suppose if this minimum time period is for machine A, you have to take the sequence, assign the job first, that is job 1 first. Suppose if this minimum time period is available in this place, you have to assign, take the job 1 last. Suppose the minimum time period is assigned for machine B means you have to assign the job last, consider the job last. If it is the minimum time is for the machine A means you have to take the job first. Okay, so this job 1 is assigned. Next you have to consider the remaining processing times, in which one is the minimum value? 2 is the minimum value. There are two available. In which one is you consider arbitrarily, you can consider any 1, 2, but normally left to right or top to bottom. Now if you consider left to right, this 2 we have to consider now. In this 2 is the minimum value for job 4, that is job 4 requires 2 hours in machine B. This 2 is available for machine B, therefore job 4 last. Suppose this 2 is available for machine A, job 4 first. This is the sequence we want to follow. This is the procedure. It is an algorithmic approach, algorithmic technique. There are various assumptions are available. There are various algorithmic approaches are available in computer science. Normally we used the algorithmic approaches. Okay, now this job 4 is over. Remaining things you have to consider. Remaining processing times, in which in all these remaining processing times, which one is less processing time? Very minimum processing time is 2. This 2 is available for machine B for job 5. So if it is available for machine B means job 5 last. Suppose if this 2 is available for machine A means job 5 first. This is the procedure. Now job 5 is last, so job 5 is assigned. Now job 5 is assigned. Okay. Now consider the remaining timings, processing timings. 3, 6, 8, 3, 3, 10. There are 3 3s are available, in which you can choose arbitrarily anyone, normally left to right or top to bottom. Now therefore in order to proceed this processing timings, that is job sequencing, this 3 is the minimum time. This 3 is available for the machine A. Therefore we can assign job 2 first. Now job 2 first, it is over. Assignment is over. Next consider the remaining time periods. 8, 3, 3, 10. Which one we can assign? Okay. Now already I told you left to right or top to bottom. Which one is minimum? 8, 3. Left to right or top to bottom? Top to bottom I consider 3 and 10. Therefore we have to consider next this 6, 3. This is the minimum value in the remaining processing timings, in which this 3 is available for job 6 and for machine A. If it is available for machine A means job 6 first. Therefore job 6 is assigned. The remaining job is only 3. The only cell is available, so you can put it here. So each and every job must be assigned. This is the sequence of jobs. This is the sequence of jobs we want to process in these two machines. Okay. How we can find out the total elapsed time, total processing time? Is there any machine ideally available during this process? We can also find out this kind of ideal time for each and every machine. Ideal time for both the machines A and B, total elapsed time for processing all the jobs. Now we want to find out. As a first step, already we did the sequence of jobs is find out by us by using some algorithmic approach. This algorithmic approach we can use. Now, then we can solve this problem. How we can able to solve this problem? Now you have to see here, these are the jobs, and this is machine A, this is machine A, and this is machine B. For machine A and machine B, there are two timings, job in time and job out time. Job in time and job out time. What is the sequence of jobs? 1, 2, 6, 3, 5, 4. This is the sequence. Already we find out in what sequence the jobs are processed in these two machines. That is actually we find out. So you have to write all these sequence of jobs. 1, 2, 6, 3, 5, 4. This is the sequence of jobs we process. We want to process in these two machines in a sequence. Now what is, whenever the job 1 enters into the first machine, it starts at 0 time, 0 hour. This may be a hour or minute or second or day, anything else. Okay. Now in job 1 enters into the machine A at 0 hour. When it completes, what is the processing time for job 1 in machine A? Only 1 hour is the processing time. When it comes out from machine A, the job 1 hour only. Okay, after completing the processing work in machine A, the job 1, then it go to automatically in machine B. When it go to the machine B, first machine A, the processing time 1 hour, after 1 hour it go to the machine B, because each and every job must be processed through machine A and machine B second. First in machine A and second in machine B. Okay. After the processing of the job 1 in machine A, it goes to the machine B. Okay, 1 hour. Then what is the processing time in machine B, the job 1? 5 hours. 1 hour it enters, the job 1 enters, which will take 5 hours. So 1 plus 5, 6 hours. So 6 hours only the job 1 coming out from these two machines. 6 hours, after 6 hours only the job 2 comes out with its processing from machine A and machine B. Okay. Now next, how we can able to proceed this problem, solving this problem? After 1 hour, machine A automatically take the job 2. This is the process. After 1 hour, automatically machine A takes job 2. Okay. How many hours the machine A taken for the processing of job 2? Job 2 requires 3 hours in machine A. So 1 plus 3, 4. Okay. Now after 4 hours, this job 2 goes to machine B for its processing. Okay. Now already up to 6 hours machine B is not free. Already up to 6 hours the machine B is not free. Therefore, but the job 2 completed at 4 hours itself. Now how we can when this job 2 enters into machine B means after 6 hours only. Simply we can take what is the maximum of these two, 4 and 6. 6 is the maximum you can put here, that is all. Okay. So, after 6 hours only job 2 enters into machine B, right. Okay. Now, next in machine B, job 2 how many hours requires for its processing? Job 2 requires in machine B 6 hours. Already job 2 enters it at 6 hours. Then it process by taking 6 hours. 6 plus 6, 12 hours only. The job 2 completed its processing from machine A and machine B. This is the procedure. Okay. Normally, in machine A, 4 hours itself the job 2 ends. Job 2 processing is over. Okay. After 4 hours, automatically job 6 is taken for its processing. Okay. Now, in machine A, job 6 taken how many hours? Job 6 takes 3 hours in machine A. So, 3 hours is the required time for job 6 in machine A, 10 hours for job 6 in machine B. Now, 3 hours for machine A for the job 6. Okay, therefore, 4 plus 3, 7 hours. At 7 hours only, this job 6 processing is over in machine A. Okay. Now, now you have to compare these two values as I already told you the comparison between 12 and 7, which one is maximum, because the job B, that is job 2 is completed at 12 hours only, but the job 6 completed in machine A at 7 hours. This machine, this job 6 waits, the job 6 wait up to the machine B is free. Whenever the machine B is free, up to that the required free time, the job 6 waits. Okay. Therefore, within 7 hours, 7 and 12 hours is the maximum value. So, 12 hours only this job 6 enters into machine B. Okay. Now, how many hours the job 6 requires in machine B? 10 hours. Job 6 requires 10 hours in machine B. So, 12 plus 10, 22 hours. Now, in the same manner, we have to process all these jobs. Next, at 7 hours, automatically this job 7 enters into the machine A. Now, 7 hours is the processing time for job 3 in machine A. So, for job 3 in machine A, how many hours requires? The 8 hours requires. So, 7 plus 8, 15 hours, the job 3 comes out from, after 15 hours only, the job 3 comes out from machine A. Therefore, it enters into machine B whenever the machine B is free. Whenever the machine B is free. Now, 22 and up to 22 hours machine B is not free, but 15 hours itself the job 3 is completed in machine A. But therefore, the job 3 enters into machine B at 22 hours. Okay. As I already told you, what is the maximum of these two? 22 and 15, maximum is 22. So, you have to put 22 here. Now, job 3 enters into machine B at 22 hours. What is the processing time for job 3 for machine B? 3 hours. So, 22 plus 3, 25 hours. Okay. Now, automatically machine A takes at 15 hours itself the next job. The next job is 5th job. The 5th job processing time, job 5 requires 6 hours in machine A. So, 15 plus 6, 21. Then now you compare 25 and 21, which one is maximum? 25. So, 25 hours only job 5 enters into machine B, but it complete as usual at 21 hours itself in machine A. Okay. Now, you have to consider what is the processing time for job 5 in machine B. In machine B, the processing time for job 5 is 2. So, 25 plus 2 is 27. Okay. Automatically, the next job enters into machine A at 21 hours itself. For job 4, the machine A requires how many hours? Machine A requires how many hours means 5 hours. So 21 plus 5 is 26 hours, right? 27 and 26, compare with these two values, which one is maximum? 27. Okay. Job 4 enters into machine B at 27 hours. Next, what is the processing time for job 4 in machine B? In machine B it takes 2 hours. Therefore, 27 plus 2 is 29. Therefore, all these jobs are completed, at 29 hours. This is the total elapsed time T. Total elapsed time T for 29 hours. The total elapsed time for this entire process is denoted as T. Total elapsed time for this kind of sequencing problem is denoted as T. The total elapsed time T is identified by solving this problem is 29 hours. Okay. Next we have to find out the ideal time for each and every machine. What is the ideal time? How we can calculate the ideal time for machine A and machine B? Okay. Totally at 29 hours only all the jobs are completed. You consider, you have to see here, is there any difference between these two? 0, 1, 1, 1, 4, 4, 7, 7, 15, 15, 21, 21. There is no difference between these two values, cross values. Whenever job 1 completed in machine B at machine, that is in after 1 hour itself the job 2 enters into machine A. Whenever job 2 completed in machine A at 4 hours itself job 6 enters into machine A. Therefore, there is no differences in these values, but there is a difference between the 29 and 26. The total elapsed time is 29, but the machine A ideally available for 3 hours. How? The total ideal time for machine A is 29 minus 6, 29 minus 6 equal to 20, 29 minus 26 equal to 3 hours. Okay, like we can calculate, initially the machine B is ideally available for 1 hour. Initially the machine B is ideally available for 1 hour. Therefore, ideal time for machine B is ideal time for machine B equal to initially 1 hour plus, is there any differences between these two? 6, 6, 12, 12, 22, 22, 25, 25, 27, 27. There is no difference. Therefore, only 1 hour is the ideal time for machine B. So, now we complete this entire problem, we solve this entire problem. We can easily identify in which we can easily identify what is the total processing time for the completion of all the 6 jobs in these 2 machines, which is found after solving this problem is 29 hours. The ideal time for machine A is 3 hours, because 29 minus 6 is 3 hours. Then ideal time for machine B is 1 hour, because initially the machine B ideally available up to 1 hour. So, this is the simple problem, like we can able to solve many kind of problems. This is an example of n job 2 machine problem. This is an example of n job 2 machine problem. Suppose is there more than 2 machines are available, how we can able to solve this kind of problem? For that we will discuss one more problem by considering more than 2 machines, that is 3 machines and n jobs. Okay. Now we will discuss what is the nature of this another kind of problem. This problem is another kind of problem in which we consider a 3 machine n job, a 3 machine n job problem. How we can solve this 3 machine n job problem? For that, you assume there are 3 machines and 5 jobs. The jobs are given as 1, 2, 3, 4 and 5. 5 jobs are available. Machine PI means printing machine. B means, that is P or B. B means binding machine and F means finishing machine. Okay. The processing time for each and every job is available here. 40, 50, 80. 50, 80 is the processing time for all these 3 machines for job A, job 1. And for the processing time for job 2 is 90, 60, 100. And the processing time for job 3 is 80, 20, 60. 80, 20, 60. And the processing time for job 4 is 60, 30, 70. 60, 30, 70. And the processing time for job 5 is 50, 30, 40, 100. 50, 40 and 110. This is the processing time for each and every machine. Here you can see that very simple, we can easily identify there are 3 machines are available: printing machine, binding machine, finishing machine. From these 3 machines, all these 5 jobs are processed. Processing time is entered into the matrix, cost matrix. Now we can solve this problem for finding the total elapsed time, minimum total elapsed time. How we can able to find the minimum total elapsed time? Okay. Now, as a first step, we have to find out the minimum value of P. The minimum value of P is 40 and the minimum value of F is 60, but the maximum value of B is 60. Why we want to consider how we can able to process, how we can find out the minimum value and maximum value? For the first and last machines find the minimum value, but for the second machine find the maximum value. This is the algorithmic steps. For the first and last machine we have to find out the minimum value, and for the second machine we have to find out the maximum value. Now there is a criteria, there is a hypothesis, there is a condition available in order to check whether the condition is satisfied for solving this problem or not. Minimum value of any one P or F is greater than or equal to maximum value of B. Is it true or not? Yes, minimum value of any one P or F. Which one is minimum value of P? 40 and 60. 60 is the maximum value. Within these two, which one is maximum you have to consider? Greater than or equal to maximum value of P is 60. So this constraint is satisfied. Therefore, this constraint is satisfied. Any one of the minimum value must be greater than or equal to the maximum value. This is the condition. If this condition is satisfied, then the problem is solved by using, as usual, the ordinary method. Okay, but we can able to find the sequence for only 2 machine problem. We can able to find the sequence for only 2 machine problem. But here 3 machines are available. How we can find out the sequence? For that, another one criteria is available. We have to convert this 3 machine problem into 2 machine problem. How we can convert the 3 machine problem into 2 machine problem? For that, G and H, I have considered this 3 machine problem into, convert this 3 machine problem into 2 machine problem. The machine 1 is G and the machine 2 is H. Machine 1 G, we can add P plus B. Okay. Then machine H, we have to add B plus F. Very simple. So first add first and second, add second and third is the second machine. Then we can able to easily convert this 3 machine problem into 2 machine problem. 40 plus 50, 90, 50 plus 80, 130, and 90 plus 60, 150, 60 plus 100, 160, 80 plus 20, 100, 20 plus 60, 80, and 60 plus 30, 90, 30 plus 70, 100, 40 plus 9, 50, 90, 40 plus 110, 150. Now, the entire problem, 3 machine problem is converted into 2 machine problem. Now, easily we can find out the sequence for this problem. Now, how many jobs are available? 5 jobs are available. You have to put 5 boxes. As usual, in the cost matrix, in the processing timings, which one is the minimum value? The minimum value is 80. The minimum value is 80. 80 appears for machine H. This is second machine. So, therefore, 1, 2, 3, 4, 5. Job 3 appears last. Suppose if this 80 available for machine G, job 3 appears first. If this 80 is appears in last means, that is second machine means you have to put job 3 last. Okay, the job 3 processing is over. Next you have to consider the remaining sequence. In the remaining processing time, which one is minimum value? 90, 90, 90. I consider this one. This 90 is available for the first machine, therefore job 1 first. Job 1 first. So, this is entirely over. Next, consider the remaining processing times 90, 90. As usual, left to right or top to bottom we have to consider. In the left to right, this 90 we consider. If we consider this 90, this is for job 4. This 90 is available for machine 1 G. Therefore, job this is available for machine 1 means we have to assign this job 4 first. Okay, this is over. Next, in the remaining processing times, the next minimum value is 90. This is for 5 and this 90 is available for machine G. Therefore, job 5 first. The remaining only one cell processing is that is job is available. This is into. This is the sequence of jobs we want to find out. This is the sequence of jobs we want to find out. Okay. Now, 1, 4, 5, 2, 3. Very simple. Like this, we have to convert the 3 machine problem into 2 machine problem, and then we can able to solve the problem. Very simple. Okay. Now, as usual, we want to find out the total elapsed time and ideal time for each and every machine. As usual, the total elapsed time and ideal time for each and every machine. Now, I have to erase all these things, then we can use. I will copy this sequence here 1, 2, 3, 4, 5, 1, 4, 5, 2, 3, 5, 2, 3. These are all not necessary for us. Only the sequence we require to solve this problem. Only the sequence is enough for solving this problem. Already there must be a this is jobs 1. What is the sequence? 1, 4, 5, 2, 3. Machine 1, that is P, machine P. Machine P, machine B and machine F. In time, out time, in time, out time, in time, out time for each and every machine. Initially, we start at 0 time. Job 1 requires 90 hours, that is 40 hours in for machine P. So 0 plus 40, 40. At 40 hours it enters into machine B. 40 plus how many hours in machine B? 50. 40 plus 50, 90 hours. Therefore, at 90 hours it enters into the machine F. Then what is the processing time? 80. 90 plus 80, 170. Automatically job 4 enters into machine P at 40 hours. 40 and 40, which one is maximum? The same. 40 plus job 4 processing time in P is 60. 40 plus 60, 100. So which one is maximum? 90 and 100, in which the maximum is 100. Okay. 100 plus the processing time for job 4 in machine B is 30. Processing time for machine B for the job 4 is 30. Okay. So 100 plus 30, 130. 130, 170. Which one is maximum? 170. So 170 plus 70 is 240. Right. At 100 hours itself, job 5 enters into machine B and go like that. This also 100. 100 plus job 5, 50 in machine B, 150. 130, 150, maximum is 150. 150 plus job 5 for processing time for machine B is 40. 40 plus 150, 190. So 240, 190, 240 is the maximum. So 240 plus job 5, 110 is 350. Okay. Then whenever the job 5 completes in machine B, automatically job 2 enters into machine P. Okay. 150 plus this 90 is 240. 240, 190, maximum is 240. 240 plus job 2 in machine B, 60 hours, therefore 300. 300, 350, maximum is 350. And 350 plus job 2 in machine B is 100, 450. Okay. Now then we can consider 240 itself. The machine P takes the job 3 first. 240 plus this 80 is 320. 300, 320, maximum is 320. And go like that. Now simply 320 plus this job 3 in machine B is 20. So 340. 340, 450, maximum is 450. Then we have to consider 450 plus job 3 in machine F is 60. So 510. Therefore, we find out the total elapsed time 510. Therefore, processing all these 5 jobs in these 3 machines, we can easily find out 510 hours. The total processing time for all the 5 jobs in all these 3 machines is 510 hours. Like we can easily find out the total, that is ideal time for each and every machine. Is there any difference? 40, 100, 150, 240, 320. There is no differences there, but at 510 hours only the total processing work is over for the processing of all jobs. Therefore, the ideal time for machine P is 510 minus 320. 510 minus 320. This is the ideal time. Okay. And ideal time for machine B is initially 40, initially 40 hours ideally machine B available. Then what is the difference between these two? 90, 100, therefore this is the difference, 100 plus 10 hours, 130, 150, difference is 20 plus 190, 240, difference is 50 plus 300, 320, difference is 20 plus 510 minus 340, 510 minus 340, 440, 100, 170. This is the total ideal time. Now, like we can easily find out the ideal time for machine F. The ideal time for machine F is initially 90 hours plus, is there any difference between 170, 170, 240, 240, 350, 350, 450, 450, there is no difference. Therefore, the ideal time for machine F is only 90 hours. So, we can able to find out the sequencing of jobs through 2 machines and 3 machines, how we can solve, very easy to understand that. I hope that you are all understanding very well easily the problems how we can able to solve.